Okay, hey guys, so today will be our first session. I'm just gonna start off with a simple and easy topic. We're gonna start off with sequences and series, okay? I am not sure how many of you all are familiar with this topic, but I figured it would have been a good place to start. If you're unfamiliar with the topic, just take it slow, right? And watch the video. If you are familiar with it, feel free to just skip through and let it serve as a reminder for what you already know. Okay, it's okay to skip through, but if you're not understanding, just start back or simply just message me, right? Okay, so let's get this started. So a sequence is a set of terms in a well-defined order. Okay, this is a definition for a sequence. Note, a sequence is separated by commas. Okay, this is different from a series, which is separated by a plus sign, right? So it's simply a list of terms in a well-defined order, right? So for the first example, the first term is 1, right? The next term is 2, the third term is 3, right? And as you could see, for each one, you keep adding 1. 1 plus 2, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. Right, so you see it have a set defined order. The next one, as we could see, it's plus 2. 4 plus 2 is 6 plus 2, right? The next one, now we could see that this is actually 2 to the power 1. This one here is 2 to the power 2, 2 to the power 3, 2 to the power 4, and so on, right? So over time, you would get accustomed to identifying these different sequences and how and yeah, sorry, first time, so taking it slow. So next thing now is that the nth term can be written by either u of n, t of n, or a of n, right? Where n represents the nth term, right? So first example, right? Using this first sequence here, for example 1, right? All this basically says is that u of 1 is equal to 1. All it's saying is that the first term is equal to 1. U of 2 is equal to 2. The second term is equal to 2, right? U of 3 is equal to 3, right? So we're simply saying now what we could derive is that U of n is equal to n. So if I want, let me say, the fifth term, right? Therefore, n is equal to 5. So therefore, u of 5 is equal to 5. It's as simple as that. Let's go to the next one. We have the next example, which we're looking at here, which is example 2. Okay, we have u of 1. Again, the first term is equal to 2. U of 2 is equal to 4, meaning the second term is equal to 4. U of 3 is equal to 6, meaning the third term is equal to 6. So from this, we could derive the expression that u of n is equal to 2 times n. Again, if we want to find the fifth term, right, u of 5, it would simply be 2 times 5, which is equal to 10. When you're finding this expression, you want to look for similarity between here and the number here. Okay, look for similarity here and here, and you'll notice a trend most of the time. Once you notice a trend, it is a sequence. Okay, so now finding the terms given the formula. Again, this is something pretty simple, guys. So if I tell you that u of n is equal to 5n plus 1, right, and I tell you to find the first three terms, again, all I do is u of 1, which represents the first term, is equal to 5 into 1 plus 1, which is equal to 6. U of 2 is equal to 5 into 2 plus 1, which is equal to 11. Again, u of 3 is equal to 5 into 3 plus 1, which is equal to 16. Again, let me say we have a different function. U of n is equal to n plus 1 over n plus 2. Right? It could be in this form. It could be in this form. It could be in the form of an plus b. It could be in the form a number a to the power of n. It could be n to the power of a number a. So it varies, okay? So again, for this one now, let me say we have u of 1 would be equal to 1 plus 1 over 1 plus 2, which is equal to 2 over 3. If we want to find the second term, it would be u of 2, right? Again, it could be u of 2, it could be t of 2, or it could be a of 2, anyone, whichever works with you, or more in particular, which one they give the equation in, right? So if they give you u of n, I would recommend that you continue using u, okay? So u of 2 would be 2 plus 1 over 2 plus 2, which is equal to 3 over 3 quarters, okay? Now, a series is different from a sequence. The difference is that a series is the sum of the terms in a sequence. So, for example, remember we had the first sequence 1, 2, 3, 4, and so on, right? Rather, instead now, a series is really 1 plus 2 plus 3 plus 4 and going, okay, right? So rather, when in a sequence, when it just listing the terms, a series actually adds up the terms. And when we write in a series, we normally use a sigma notation, right? Now, this is how a sigma notation works. This is the sigma sign. It kind of looks like an E, something like a Z combined, I don't know, right? And how we're using this is that we say from R is equal to 1 to N, right? Where N is a number of, let's say, R, okay? Or it could be anything here, right? Note that whatever you have, the variable you have here must be the variable here. Because so basically, let's say example, we have from R is equal to 1 to 2 of R, okay? What this means is that we have, when R is equal to 1, you have 1, then next value is 2, and then you add them up and it's equal to 3, okay? Again, let's say we have the sum from R is equal to 1 to 3 of R squared. What this means is that you're taking 1 squared plus 2 squared until you reach this value here of 3 plus 3 squared, which is equal to 1 plus 4 plus 9, which is equal to 14. Okay? That is all that this means. Again, if we have, let me say, the sum from R is equal to 1 to 5 of 3R, all this means is that you keep substituting this value of R. So it would be 3 into 1 plus 3 into 2 plus 3 multiplied by 3 plus 3 multiplied by 4 plus 3 multiplied by 5, which is equal to 3 plus 6 plus 9 plus 12 plus 15. Okay, so we have 6 plus 3 is 9, 9 plus 9 is 18, 18 plus 12 is 30, 30 plus 15 is 45, right? So rather than going through this entire long process of multiplying and writing out all these terms, it have a simpler way to do it. Because just imagine someone gives you a term like the sum from R is equal to 1 to 1,000 of R. Could you seriously write out all these terms and add them up? No, because that wouldn't make sense, right? So what we have now is a list of equations that we could use to help us solve these things, right? So these are the equations that we need to know, okay? So the sum from R is equal to 1 to n, right, of R. Remember, for this equation to work, you must start at R is equal to 1, okay? This value here could be different, but we need to start at r is equal to 1. Otherwise, you have to change the equation, okay? And in some examples, which I will do in our next video, I will show you all how we change this, okay? So this is a setting. So the sum from r is equal to 1 to n of r is equal to n into n plus 1 all over 2. Okay, so again, let's say for example now, right? So this is the one we need to know. Actually, I should write it in red so that it would blend in and look normal. So it'd be n into n plus 1 all over 2, right? So for example now, let me say we have the first one above. We have from r is equal to 1 to 2. So let me say we're going to find the sum from r is equal to 1 to 2. Okay, this is equal to r, sorry, this of r, right? Sorry, yeah. This is equal to n, so we take this value. So in this case, we see n is 2. So we take 2 into 2 plus 1 over 2, okay? And 2 plus 1 is 3. 3 times 2 is 6. And 6 divided by 2 is 3. And as you can see, we got the same answer from above here. See? We got the same answer. Alright? The next one now is if we're using the sum of r is equal to 1 to n of r squared. So it's kind of like this one we did here, as you can see. Okay? So in that one we did 3. So and this equation is n into n plus 1 into 2n plus 1 all over 6. And I went ahead and wrote with the blue one, but that's fine, okay? I'll just leave it, right? So this is the example for this one. So the example for this one, right? I'm going to do the same thing so we can make sure that we get the same answer. So we're going to find the sum from r is equal to 1 to 3 of r squared. Basically, what we're adding again is 1 squared plus 2 squared plus 3 squared. Okay? But let's see if this works. So we're using the equation, so we'll have 3 into 3 plus 1 into 2 into 3 plus 1, right? All over 6, right? This is equal to 3 plus 1. Okay, so first here, 2 by 3 is 6. 6 plus 1 is 7. 7 times 3 is 21. And 21 multiplied by 4 is 84 all over 6, which is equal to 14. And if you remember, we got the answer here as 14, right? So this shows you that this equation works. Another last one is if we add an r cubed. So this equation is given by, and I'll remember to change the marker, n squared into n plus 1 all squared all over 4. Okay, so for example now, let's say we example, okay, we have the sum from r is equal to 1 to n. So let's say n is 3, right, of r cube, right? What this means is that we are adding 1 cube plus 2 cube plus 3 cube, right? This is equal, if we work this out here, is equal to 1, 2 by 2 is 4, 4 by 2 is 8, 3 by 3 is 9, 9 by 3 is 27, which is equal to 36. Okay, so let's see if we use the equation now and get the same answer. So what this equation says that it will be 3 squared into 3 plus 1 all squared all over 4, which is equal to 9 times 3 plus 1 is 4, so times 4 squared over 4, which is equal to 36. So we get the same answer. So this proves that the equation works. Again, remember, all this says is that we add in 1 cube plus 2 cube plus 3 cube. Okay. So now we have some summation laws. I was kind of hoping the videos wouldn't be this long, but feel free to skip through again if you know these things already. So the next one now is the sum from r is equal to 1 to n of a constant c. So this c here represents a constant value, meaning it could be 1, 2, 3, okay? So the sum from r is equal to 1 to n of c is equal to n times c, okay? Now, for example, right, let's do the sum from r is equal to 1 to, let's do something simple, to 3 of the value 2, okay? All this says is that if we want to find this value, it is equal to 2 times 3, which is 6, which is correct. Because all this simply means is that we adding the value. What this relates to is 2 plus 2. When r is equal to 1, you have the value 2. If r is equal to 2, you still have the value 2. And if r is equal to 3, you still have the value 3. And that is 6. So this is how you get this one, right? This one says, let's say you have a function as u of r. Let u of r be a function, right? It could be r squared, r cubed, right? And we multiply it by a constant c. What this says is that this is also equal to c times the sum of r is equal to 1 to n of u of r, okay? That is all that this says, right? So for example now, let's say we have the sum from r is equal to 1 to 3 of 5r. All this says is that this is equal to 5 multiplied by the sum from r is equal to 1 to 3 of r, which is equal to 5 times, and remember, we know our equation for this. We have an equation for this. The equation for this, if we recall, is n into n plus 1 all over 2. So this is equal to 5 times 3 into 3 plus 1 all over 2, okay? Which is equal to 15 times 4 over 2, which is equal to 30, okay? And again, all this is equal, all this is you have 5 into 1 plus 5 multiplied by 2 plus 5 multiplied by 3. And when you add this up, you also get 30. So we know that this rule works since we get the same answer. Now, this one here says now, if you have two separate functions, so let's say you have the sum from r is equal, so this actually is equal to the sum of r is equal to 1 to n u of r plus the sum of r is equal to 1 to n of v of r. So again, how this works is, let me say we have the sum from 1 to 3. I'm using small terms so that they would be easier for you to understand, so you can make sure that it works for yourself. Okay, so if we have the sum from r is equal to 1 to 3 of r plus r squared, okay, what this says is that this is equal to the sum from r is equal to 1 to 3 of r plus the sum from r is equal to 1 to 3 of r squared. So if you recall from above here, we know that the sum, recall the same equation, we know this is equal to 3 into 3 plus 1 all over 2 plus the sum for r squared. And if we recall r squared, recall that this is equal to n into n plus 1 into 2n plus 1 all over 6, okay? So this would be equal to 3 into 3 plus 1 into 2 times 3 plus 1, which is 7, okay, over 6. So this would be equal to 6, because 3 plus 1 is 4, divided by 2 is 2, times 3 is 6, plus 3 divided by this here you get 2, then this here you would also get 2. 2 times 7 is 14, so you would get 20. Okay, did I do that correct? I believe so. Okay, so again, if you're not sure, just double check. So we'll do what this says is that this is equal to 1 plus 1 squared plus 2 plus 2 squared plus 3 plus 3 squared, which is equal to 2 plus 2 times 2 is 4, 4 plus 2 is 6, plus 3 times 3 is 9, 9 plus 3 is 12, and we get 20. So we know that this works as well, right? Now, one thing I need to warn you about is multiplying. So let's say that we have the sum from r is equal to 1 to n of r plus 1 multiplied by r plus 2. This is not equal to the sum of r is equal to 1 to n of r plus 1 multiplied by the sum of r is equal to 1 to n of r plus 2. This is not equal to each other. If you want to solve this equation, you need to expand it out, okay? So you need to expand this out into the sum of r is equal to 1 to n of r squared plus 3r plus 2, okay? And then you break this up now into the sum from r is equal to 1 to n of r squared plus 3 times the sum of r is equal to 1 to n of r plus the sum of r is equal to 1 to n of 2. And we should be able to do this, right? Because we know our equation to find this. We know our equation to find this. And we know an equation to find this. And notice here that I also used one of these summation laws, okay? So we could solve this, right? So this is all you need to know for series and sequences. Again, know these rules here in particular, you're gonna need them when solving, right? In addition to this one, right? Also know these three. You're gonna need them to know what to substitute, whether it's r squared, r cubed. You don't need to know any more than that for the CSEC level, okay? So just r squared, and r cubed. And these are what you need to know. Again, the series is when you add any terms of a sequence, and a sequence is a list of terms in a well-defined order. So that was it for this video on series and sequences. Please look forward to another video where we do questions on series and sequences so that you all would better understand it. Okay, so that's it for the first video. Let me know how this went, let me know any improvements, and I will definitely take it under consideration before I make any more videos, so at least I could get an idea of how to improve them so that you could better learn. Okay, thank you. That was it for series and sequences theory.